All right, hey, what's up, everybody? We'll get started in a couple minutes. Yeah, I'm gonna get set up over here. I'll try to drop some links in the chat while I get set up. So, all right, the two collabs we're gonna be working with today are where's my DeepDream? Here. So I'll talk about this in a minute, but just so everyone has these links, I'm gonna paste them here. So that's the first one, and this is the second one. All right, it is 2:05, so we'll try to walk through it, but you might want to check out that video just to know a little bit about like how machine learning works. Today I'm maybe talking about DeepDream. DeepDream actually works a lot like style transfer. It's just the outputs are different. So the thing to remember is that we're working with a pre-trained network, and it's also important to remember that these are like basically the building blocks of machine learning, especially for image generation. So I'm just going to pull up some images. So I actually haven't done a lot of DeepDream work before. In prep for this week, this is the first time I'd actually sort of play with it a little bit. So if we just, so DeepDream was probably one of the big famous machine learning models for a while there. As you'll see, it has a very strong look, which I think is why I don't use it very often in my own work. But I think it's really interesting, and I think it actually helps explain a lot of different things about how machine learning works, especially as convolutional neural networks work. So I think we've talked a little bit about, let me pull up also what a convolution neural network. So these are diagrams of just sort of how neural networks work. I'm trying to see if there's a good one here. This one's probably the best. So you'll see that a lot of what we're going to play with today are actually these different layers. So style transfer worked in sort of a similar way, which is that it would pull out different layers as content and another layer as style. So one of those styles would be like the texture layer, right? So different layers here have different attributes. Basically, as they start as they start with just like general textures or like lines or shapes. Actually, really just lines, just edges. When they have this middle layer, they start to become more shapes, like more geometric shapes, or not even necessarily geometric, but just more shapes. And as you get further and further down these layers, so down to like this layer, it's really about how it finds almost whole faces, or as we'll see, it'll find full dog faces, that sort of thing. So style transfer was working where it would take this layer, which was really the content layer, and add the style layer, which was sort of this middle layer. DeepDream does sort of the same idea in that it takes a lot of these layers, but what it does is it actually reverses them. So it helps you see over an iterative process, it actually builds up those layers and highlights how a neural network sees things. So we're just going to go through two DeepDream notebooks today. I'm just going to walk you through them. They're both linked to here in my ML Art Collabs repo. We're going to look at two of them. The first one is going to be this minimal DeepDream implementation, which is from the folks at TensorFlow. This is just going to give us sort of a basic overview of how the thing works. And then we're going to look at a more advanced version, which is from Alex Mortvinsev. Sorry if I butchered that last name. He actually was one of the creators of DeepDream. So he's got a notebook here that's pretty cool and does a lot more stuff. I think it's also going to show us that there's a lot of power in using Colab in ways that you might not get out of just using a server. So I think this will be a pretty cool demo. I don't know, we'll do 30, 40 minutes, and then I'll save some time for questions at the end. So if you have questions, feel free to drop them in here, and we'll take a look at it. So cool. Let's get started with one of these. So I'm going to start with this minimal DeepDream implementation. Actually, let's go back just so I have it. So this is written by the TensorFlow folks. This is actually just built on TensorFlow. So it's pretty nice in that most of the stuff here is already set up. We're going to find out so just recently Colab moved to TensorFlow 2.0. So I'm not sure if this is actually set up for 2.0 or not. So we might have to figure it out. So we'll go through it and we'll see. So again, what I really like about notebooks is that you can just sort of read and then you can play with stuff and then we can go from there. So this tutorial contains a minimal implementation of DeepDream, as described in this blog post. DeepDream is an experiment that visualizes the patterns learned by a neural network. Similar to when a child watches clouds and tries to interpret random shapes, DeepDream overinterprets and enhances the patterns it sees in an image. It does so by forwarding an image through the network, then calculating the gradient of the image with respect to the activations of a particular layer. If you don't have any idea what that means, it basically means what I just described, which is that like these networks are meant to find certain shapes. And in this case, all we do is we feed it an image and it over-indexes for certain shapes or certain images, that sort of thing. The image is then modified to increase these activations, enhancing the pattern seen by the network and resulting in a dreamlike image. This process was dubbed Inceptionism. I don't know why you would call it that. It's really just like a reference to InceptionNet, which is one of these pre-built networks that I talked about last week. Okay, so this is just going to walk us through how to actually make one of these images. So again, with Colab, the way that I sort of start is I'll just like start reading through it. You can run each of these cells as you go through. So we're just going to come here and we hit Shift Return. That runs the cell. It's going to connect to a network. Let me make sure my runtime is set up right. Runtime. Change runtime type. I'm just going to set it. Since I have Colab Pro, I'm just going to set it to high RAM just so it runs a little bit faster. That might mean I have to redo some of this. Cool. All right, so we're going to run this. This is just importing a bunch of libraries that are already built into Colab. For this tutorial, let's use an image of a Labrador. That seems fine. Although, actually, you know what? Let's upload our own image. Let's not use a Labrador. So let's just do this. So let me find an image here. Let's play with an image. Let me come into Dataset Tools. That's kind of a cool image. Let's use that. Okay, so I'm just going to drag this into Colab. It's going to upload it. And I think what I'm actually going to need to do is not necessarily use URL. I'm just going to want to take this and actually just going to comment this out. This is like to basically download an image. Well, you know what? Here's what we're going to do. We're going to keep this because it's doing a bunch of resizing and stuff. So we're actually going to keep this, but we're instead going to say this might work actually. Let's just try it. I think it might throw an error too. Let's see. Okay, so we're going to set that as the URL. We're then going to run this, which is meant to download and install it. Yep, okay, so here's the first thing we run into. This will happen a lot right now because you just moved to TensorFlow 1, we just moved to TensorFlow 2 inside of Colab. So we're going to start to need to use this magic command, which just sets it to TensorFlow 1.15 or whatever. So we're going to rerun this. We'll have to like start at the top and start rerunning these again. I got to restart my runtime. Which means I'm going to need to re-upload that image. So while that happens, I'm actually going to find a better image. I think the crop on that is going to be weird. Okay, I'm going to open this in Photoshop. Or maybe I can just open it in Preview. Let's see. Yeah, okay. Files, export. Let's go to desktop. And let's save it as a JPEG. Cool. All right, so now I got a new image. Come back over here to Colab. This is now not running. Great. All right, so now we're running. Now I'm going to start running these cells again. Some of the annoying parts of Colab are being shown here, which is like if you hit a snag, sometimes you have to restart your whole machine and start again from scratch. Well, that works. I'm going to upload this. Cool, it's uploading. Run this cell. And then we need to change the name of this. So copy path. I'm going to paste the path in here for the URL. Let's see, unknown URL type. Okay, so I think we have an issue here, which is that I think this needs to be off. Let's just try this again. Open, I think we just want URL here. Name is not defined. Let's try this. Of course. Maybe I don't need this. Oops. Let's try that. Cool, that worked. Okay, great. Basically, it's like it's trying to actually do a URL find, and because this is a local file, it's like not finding it. But that worked. Cool. So I now have an image in here that's set up. This is not the correct CC, but whatever, it doesn't matter. Okay, so now we're gonna get set up and start building this thing. So this is you'll see it's loading something from Keras. Keras is like an API that sits above TensorFlow. It makes reading things a lot easier. We are going to use the Inception network, which again is just a pre-built network, and it is trained on a thing called ImageNet, which I think is Google's like big repo of images. Basically, all we're doing is we're loading in a pre-trained model. Cool, so now it's downloading. While it downloads, I'm just going to read this here. So the idea in DeepDream is to choose a layer or layers and maximize the loss in a way that imaging increasingly excites the layer. The complexity of this features depend on the layer you choose. So again, lower layers are going to produce strokes or simple patterns, while deeper layers give you sophisticated features in images or even whole objects. The Inception v3 architecture is quite large. For DeepDream, the layers that we're interested in are those that are concatenated. So basically, like the way layers work is they start by like sort of separating them, and then they compress them down into like a next layer. So they're basically like telling you which of these layers they want to use. So there's mix 0 through mix 10. Those just happen to be the names of the layers. So each layer is going to give you a different name. Or each layer has a different name, and each layer is going to give you a different image. So we can just test this here, and we can just sort of see what does it look like if let's actually get just mixed 5. So I'm going to pull this out. So I want to use just the mixed 5 layer, which is right about the middle of all these layers, because there's 11 total. Yes, bug, hi. So let's just look at this and sort of see what happens. So now grab this, or just sort of said like, hey, these are the layers I want to work with. Now if we do this and we calculate the loss. So calculating loss is essentially a way of how different is the image from what it's expecting to find. Don't worry about this too much. Gradient ascent is the opposite of finding the like lowest point in like the gradient, or like trying to train back what's called like a backward pass. This basically just says like, hey, let's try to excite those layers. Let's try to push them as far as we can. So we set this up, and now we're ready to go. So actually we can just run this, and our network is set up here. So now we want to run a loop. So the way that this works is it actually loops over the image multiple times. See here, there's a number of steps, and there's a step size, and all of these steps, basically it like starts and it finds a little bit of this excitable layer. Then it runs again, and it increases that excitement layer again and again and again and again, until it basically like over like it's almost like sampling or like over generating an image, so that it begins to create a new thing, or like highlights what it sees or what it tries to find in that layer. So if we define this run, and then we can finally run it here, this is going to generate a pretty like, oh, interesting. List of tensors expected when single tensor. That's interesting. Okay, I wonder if I broke this because I only gave it one layer. Put this back in. Let's rerun this. And let's see if this is what we need. Cool, that's interesting. Original image, steps of 100. Okay. So there's some fun errors to see here. Make sure that our image is defined here. So, original image. Just going to run this again to make sure I caught everything. Where does this get saved to? I guess maybe just locally. Let's try this again. Yeah, fun. The joy of live streaming. All right, let's try something else. Let's, maybe there's something wrong with this image, so let's go back to their, ooh, interesting. Am I going to be able to undo that? Yes, I can. Awesome. Undo is done by cell. Amazing. That's a very helpful feature. So let's try this again. Let's just try their dog image and see if, sometimes what will happen is that, no file or directory. Cool. We're having all sorts of fun with this Colab today. Well, it sure looks like it works. Oh, I think it's because I need to do image path. Yep, that's a dog. So I think if I just run this down here, it should just work. Nope. Awesome. Well, this is a fantastic first attempt. I have no idea what the error is here. I actually ran this last week and it worked fine. Not the end of the world. We can actually just go to that other notebook and play with it, and I can show the same things. I have to say, this notebook I actually had a bunch of issues with, so I'm kind of glad that this one broke. So let's just look at the other notebook instead, unless someone in the chat has an idea what's going on. Oh, so actually, this is a great time. I'll just answer some questions now. So Nato asks, I haven't used Colab for some time, but is this upload feature only for Pro or for free license as well? Yes, you can upload any image you want to the main. It's basically like you can upload images. The thing to remember is that uploading images are only available for the session that you're running. So if I were to restart my runtime, and I'll just do this because I'm going to move on to a new notebook, but if I reset this notebook completely, I lose my image. So that's the difference, is like you can upload any number of files here as you want, but it will immediately delete them when you're done. Okay, my cat is killing me right now. Come on, baby. Everyone say hi to Bug. Okay, so I'm going to jump to this other notebook because clearly this one's kind of borked, which is funny because it's the TensorFlow people, and you would think Google works with Google, but it doesn't always. I ran this notebook earlier today, so I know for a fact it works. Which is fine. This is actually a better notebook to walk through and like to learn from, so it's probably better anyway. Okay, so I'm going to come up here. The one thing I know I need to do with this is I know I need to convert it to TensorFlow 1.0, which is up here. So if you ever run into TensorFlow issues, this is the magic command you need to use. I'm just going to paste to the top of the cell. I'm going to open this in playground mode. Bug, you're really annoying right now. I'm glad you're happy though. Okay, so this is a new notebook. This is the second one. This is the one I talked about from Alex Mortensev. He happens to be one of the creators of DeepDream, so he's got some cool little features in here that we're going to play with a little bit. So this is running. Essentially what it's doing is it's just grabbing TensorFlow version 1, and then it's downloading some models and some other things. It's also downloading the Labrador image, but we're going to do a different image. So this is actually written a little differently in that it's a lot of the code is already here in the cell. So we've now run that cell. Let's move on to this cell. So there's a cool feature that I don't use very much. I feel like I probably should more often. Inside of Colab that allows you to upload files directly from the cell. So if you run this cell, and it's a little bit of command of importing some Colab features, and then you can upload an image. So let's just upload an image here directly. Cool, so we're just going to grab this and upload it. So what you're starting to see is like you can use Colab to do some really interesting interactive stuff. And this notebook has a lot of like pretty cool features to allow you to do some of this stuff. This is going to take a little while to upload, but I'll walk through a little bit of how this works. So we're going to load the image. We're going to install a bunch of DeepDream code. This is basically the similar to like what we saw in the other notebook, which is like adding in some of the functions to resize images, to calculate gradients, to render the DeepDream image. And then we've got these cool little slider features here. So again, because we're in an interactive notebook, we can actually play with some of this stuff and then render images that way. So we're going to take a look at this once this image is completely uploaded. This is clearly a huge image. And Colab, I have to say, is a little slow with uploads. It's one of the more annoying features. So as with all things with Colab, it's like the benefit is it's free. The trick is that there's a lot of like little annoying stuff you have to work around. So I haven't connected my Colab notebook to my Google Drive, but I could do that. For this sort of work, I probably don't need to, just because it is, I'm only creating one image at a time, right? So I'm not actually really doing any training. I'm not doing any like bulk image creation. So in this case, if I like an image, I can just download it. It's much easier that way. But I could connect my, if you come over here and you hit Mount Drive, you can connect your Google Drive to Google Colab, and then you can do some stuff where you can pull from images that are already in Drive or save images to your Drive. This looks like this uploaded. I'm going to run this cell, which I don't think I actually need to, but just in case, it's helpful too. So let's load the starting image in here. Probably should have scaled this image down. It's clear that it's like losing its mind trying to upload this thing. There we go. So it's obviously a very, very large image. When you load a very, very large image into an array, which is what you're doing here, you're loading every pixel in, and it just takes some time. So that was why that was slow. Going forward, it's going to actually resize the image, so it should be less of an issue. We're gonna run this code, which again just sets up the a bunch of commands that we need. It's totally fine if you don't understand what any of this means, because all you really need to worry about is when you start to play with it. Cool, so now we've got this set up. So now let's just run the first image. So we're going to run this with a bunch of the default networks and the default layer, which is mixed for C. So you'll see they've also listed a bunch of options here. So let's just run this. That might be why. I'm not running my high RAM. That's right. It's a little slower. Oh, you know what else? This isn't scanning the image. This is going to take a while. Okay, one thing I'm going to do really quickly here is I'm going to resize this image. in Photoshop for myself really quickly. Of course, never mind. Let's do an image viewer. Yeah, no wonder. This is a huge image. So let's just make this a little bit smaller. Let's make the height 500. This will help us generate these images faster. And I'm going to save this. And I'm going to cancel this command. This is insanely huge. I would be shocked if it actually worked. So let's upload this again. And you know what? Cancel this. We're just going to delete this image. And then we're going to hit this file again. We want this one. So much quicker. Okay, let's try this again. I don't think I ran this cell. Let's run this cell. Oh no. All right, well, okay, that worked. Let's run this again. Basically, it had the old file saved in here. So now if I run this, it should run a lot faster. Cool, yes, much faster. All right, great. We don't need to rerun this cell because we already saved all of this to our runtime. We're going to save this here. Cool, all right, so now we've got a small image that has been run through our network. And you'll see here that already we're starting to see some textures. You need to go behind the computer. So now we're seeing some textures, right? We're seeing what we've sort of have referred to from folks as the puppy slug. You'll see a dog is starting to appear within this image. You'll see some other textures here. You'll see there's a bunch of weird textury patterns here. So there's a couple things we can do with this image to already start to enhance it. There's already a thing called octave, which you could play with. Octaves just mean how many more times does it run. There's an iteration, which is also octaves and iterations sort of work together. So one thing we could do is we could crank up the iterations. So let's crank it up to, I don't know, what does it crank up? It goes up to 50. So let's try, I think it was at 10 before. Let's try about 30 here. And if we rerun this cell, you'll see this leaf has started to grow some legs. And you'll see it's just a little bit more intense, right? Because we've been running through that repetition pattern a little bit more. We can also crank up the strength, which I think will actually sort of change some of the colors a little bit more, and also give us a little bit more of that like psychedelic look. I think it also sort of makes the image feel a little bit crunchier and a little more pixelated, which is the downside of this. But if we run this, yeah, so you start to see a little bit more of this. It has like a lot more sort of contrast to the image, but you do also see way more dog faces appearing in these flowers, a lot more dog legs that are starting to appear, basically because it's starting to find this dog face in these patterns, and it knows that at this layer that dogs also usually have legs, so it's starting to generate legs for these things too. So if we choose a different layer, so this is the mixed 4 layer, which is pretty deep into our network, right? It's finding dog faces. If we go to let's go to mixed 3, which is like a very early layer. And if we run this again, you'll see it's actually just going to find not dog faces, but it's going to find more textures and more shapes. So you see, this is a very different image, but it's very geometric. It's very patterns and shapes and that sort of thing. So no more dogs. But you will see that almost starts to appear like eyes, right? And that's what happens with these layers, is when you start with an early layer, it's just general shapes. And then as it gets deeper into the network, it learns more like realistic sort of shapes. So it can take these eyes and combine it with other things that might be more like eyebrows or like noses. And that's how it finds later layers. So if we go through each of these layers, so let's look at mix 3B. You'll see this one is still pretty geometric, but it's like almost pure circles and pure swirls. If we look at mixed 4, which I think is the one right before what we had, you'll see This is still pretty animal-like, but it's almost more like monkey shapes. The noses are a little different. Yeah, so you'll see it. It's about a lot of eyes, a lot of faces, those sort of things. Now, if we look at 5A, which is the deepest available to us in this example, this one looks like what? A fish? Other sort of shapes or animals? Oh, parrots maybe. So this is like, again, it's like the parrot-fish layer. You've got some other bird-like things. So again, I could turn my, let's turn my strength down. That way it's not as crunchy of a looking image. And what I like about this is that because of these sliders, you can sort of get a sense of how things are changing. Whereas if you just punch in a bunch of numbers, you're not exactly sure what you're really doing with it. But it's sort of helpful to sort of combine these and just sort of understand how this works. So if I turn octaves down, this should make the image a lot less obvious. It's going to be more subtle. So you'll see it's less blowing out the bigger features and more just looking at like smaller details. So it's finding, eyes or faces in smaller clusters of these flowers rather than like looking at the entire leaf as one big structure. So you could crank this up even higher. And what it might try to do is it might try to look at just the overall flower structure as one thing itself. And you could run this. And you'll see it's like trying to like find in this huge cluster of images, finding one image. Done? Cool. So this is a really fun thing to play with. Like you can just upload images and play with it over and over again. To upload a different image, all you want to do is you'll want to come in here, you'll shift return on this folder, upload your image, and then make sure you run this again because this does actually set. I thought originally this wasn't helpful or wasn't necessary, but you do actually need it because you're adding this to this file contents variable, which is then getting used everywhere else. So this is the most basic version of using DeepDream, but there's also some cool features in here that allow you to do even more. So this looks at layers, but there's also a way to look at individual neurons. So if you remember, like let's say if we go back to the puppy slug image. Right, so it's finding dogs. What's actually happening is there's a bunch, inside this layer are what we call a bunch of neurons or activations. And each of those activations could be trying to find a nose, it could be trying to find an eye, it could be trying to find fur. So what we could actually do here is we can actually look at those individual neurons and try to excite those individual neurons. So if I come up here and I just take, let's see, I want to do 4C just to sort of look at the 4C network here. So let's go 4C. And then we can look through the feature channels. So channel is another way of describing a neuron, right? So this is going to look at, what, there's a number of neurons inside of each layer. So you have to sort of play with these, and if you go too high, it'll let you know. So like, I'm gonna actually crank this up all the way. I think it'll throw an error. Let's see. Yeah, so you'll see feature channels exceed size of layer for mixed C feature space. So we actually need to choose a smaller layer. So let's go down to 48. This just requires a little bit of playing around. I'm sure someone somewhere has gone through every one of these layers or every one of these neurons and like named the neuron that it affects. So it's kind of fun to just sort of see what this plays with. So look at what this layer is. This is like a layer that is looking at almost just purely like textures, right? So this is like a threading texture or something. But you could easily see that combined with maybe another layer, another neuron, and that could generate fur, right? This could be a fur texture, that sort of thing. So we can just play around with these and just sort of choose a bunch of different layers. And this is a cool because now you've got a bunch of different ways in which to tweak or edit images. This is like a mountaintop or like a plateau layer. And one thing to know is that it took me a minute to figure this out, but it's actually using these strength and octave numbers up here. So if you actually turn this down, you can edit it here. You need to run this just to save those numbers. Maybe. Actually, you might not need to run it. No, it's probably saving it to a variable. So I would save it to a variable here. And then you can run this again down here, and it's going to take your settings from up here and apply them down here, which is a little messy, but it works. So you'll see now my plateaus are a lot less strong and only looking at sort of smaller areas rather than looking at the entire image. So similarly, I can go to my mix 3, which is one of those early networks that was more shapes and patterns. And I can run this again. And you'll see this is like a very, very fine texture. It almost looks like maybe it's looking like paper texture, that sort of thing. And if I crank it up, my guess is that at some point this will say there are not this many layers. Oh, all right, cool. So you could play with this for hours. You could tweak each individual channel to sort of understand. Like I said, I haven't seen anyone that has actually named each layer, but I'm sure you could probably find someone who has actually gone through and listed out what many of them look like. So you could spend a lot of time just playing with this. This is a cool texture. And each of these layers, again, as you go higher up in the numbers, you're going to see more fully blown out features. So it'll be faces of animals, or what did this default to? I think it defaulted to this one, and I can't remember what the channel was. But that was a flower texture almost. So it was flowers on flowers. That exceeds what I need. Try something lower. All right, cool. So that's sort of just playing with individual neurons. So this is helpful in just sort of understanding the layer complexity of how complex are the features. And then I really like to play within the feature channel to really expose different things from there. Because you'll see a lot of people, there's apps out there that will basically do this for you. But this is where the fine-tuned work really gets into, and this is where you can have some fun playing with it. Last thing I'm going to show, I believe, last thing I'm going to show, well, we'll come back to that maybe. We'll see. There's a way to do iterative zooming. So I think this is something that I think Gene Kogan has done a lot of. I think if this loads, yeah, there we go. So you'll see there's this technique of sort of zooming in as you iteratively zoom through it. So there's a way to do that in this notebook. It won't save out individual frames. So you'll have to do that sort of while it runs, or find a way to rewrite this process to save out all of your images. But there's a way to do some zooming in this. And zooming is pretty cool because it generates different images as you go through each zoom. So let's choose sort of a middle network here. And we can run this on our image, and what it's going to start to do is it's just going to start to zoom into each frame. You see it's iterating and it's zooming in. That was my cat stepping on my computer, by the way. So you could pretty easily just take this frame here, and you could probably just using Pillow, save it to your Colab, and then download all those frames, and you could generate a video from it. So one thing you might want to do is you might want to actually crank down the zoom factor, and you might want to crank up the zoom steps. So this is basically zoom steps up to 20. So if you turn zoom factor down, you'll get much more of just a more interpolation. It'll be a little bit smoother. And then you can also play with sort of how many iterations you want to do and what the strength is. So let's go to puppy slugs. Let's finish off with some puppy slugs because those are always the thing people know about. And we'll run this again with some puppy slugs. So Sean, that's a great question. I don't think that, or like basically like so Sean's question is, are the channels that are near each other numerically, i.e. 201 and 200, looking for similar things, or are they numbered arbitrarily? So it's more like if you're in a layer, those layers are, everything inside those layers are pretty similar, but I wouldn't necessarily say that everything next to each other are the same images. But we can actually try it. Let me stop this. Let's come up here and let's look. So if we look at, so right now I'm going to choose 4C, and we're at layer 78. So let me just make this, let's just make it 80, and let's run it. My guess is that it's going to be a little random, in part because this works with a mathematics property where it doesn't really it doesn't actually know what it's finding. It's just sort of generating findings. So my guess is that it's going to be more, it will be more random than we expect it to be. But again, within all those layers, they should all be pretty similar shapes, just in the way that they work. So I'm going to crank up the iteration here a little bit, just so we can see a little bit more of how this finds. So 80 is this sort of swirly pattern. Remember, I'm actually pretty deep in this network. So, but my guess is that they're not going to be that similar. Yeah, I mean, you can sort of see like this is definitely not the same as 80. And I bet if I think it was like, let's go to 79. 79 and 80 are pretty close. I mean, the thing to remember about these is these individual neurons add up to all of mixed 4C. So all these layers add up to basically trying to find puppy slugs. So if we go 20, so these will all be pretty simple in terms of textures. That's a pretty cool texture, actually. I like what that does with the basic backgrounds. So it's probably worth playing around with. I have to be honest, I have not played around a lot with DeepDream, but actually someone requested this week that I do a demo with it, so I thought I would look at it. Yeah, so what did we learn today? We learned that this TensorFlow notebook sucks and we shouldn't ever use it, so don't use that one. We learned that Alex, who of course is the creator of DeepDream, has a cool notebook and his works really well, and has a lot more features, so it's worth playing around with this. So I think DeepDream is pretty interesting. I mean, again, it pretty clearly gives you that very machine learning look, but I think there's some interesting things to play with. The other thing you could do is you could actually upload a much larger image, and I bet when you do much larger images plus your iteration and strength and octaves, so if you were to crank up the octaves on a bigger image, it's still going to find lots of really interesting stuff. So I think there's lots of things worth playing around with in here. I will say, Gene Kogan is one of those guys who's done a lot of work with it. Another person is Mike Tyka, who was on the DeepDream team. He has also done a lot of work with DeepDream. Let's see if he has any work here. So there's a ton of work here with different DeepDream images. So I would say in my personal opinion, it's maybe been sort of done, but I think it's worth exploring and just sort of seeing what you end up with. It'd be fun to find what this weird eyeball layer is. And what Mike might even be doing here is might even be doing a low level pass and then taking that same image and doing another pass on top of it. There's just lots of interesting things you could do with this. I would also be interested in seeing how you could explore this, do this as just a way to make some materials and then actually take it into Photoshop or another tool and generate another thing on top of it. So don't let DeepDream just be the end result, because it's pretty clearly done by DeepDream, but you could do more with it from there and make it really interesting. So there's also some other stuff in here in this model, which is this will tell you how to visualize each layer. So you could actually export all of this and see every single individual layer. That would be pretty interesting. And I've also noticed that Runway, which I don't talk about much in here, is Runway has a tool where you can also mix the amount of layers. So you could say I want 50% of mixed 4A and I want 50% of 3C, and you could combine them together. This is pretty interesting. I have no idea what this is, and I haven't really looked at it that closely. So this is a really cool notebook. It's totally worth playing around in. And you'll probably be able to also see some really interesting things. Like I know this is a way to actually visualize the network graph. Did that do anything? I don't think that did anything. Well, maybe this one doesn't work. Yeah, it doesn't look like it does much. But I think there's a lot worth playing around in here. So check it out. Let me see if there's any other questions in here. Sean, okay. Couple more questions. Yeah, I got time. In the iterative zooming, is it just re-rendering the zoomed in pattern at a higher resolution, also re-rendering the feature generation on the image as it zooms? So it's iterative. So it's taking the image it already produced, zooming in on it a little bit, and then re-rendering it on top of that pattern. So what it ends up doing is it ends up exciting more new layers and finding new pattern clusters as it zooms in more and more. So it's generally like producing like, again, I think if you look at what Gene had done, which I don't know why that thing is freaking out, what it's really doing is it's generating different textures at different scales, right? So at one scale, it's finding, or at least in Gene's version here, at one scale, it's finding snake patterns or mealworms patterns, and then as it zooms in, you might be changing the layers, and then it starts to find dog in those layers. In this DeepDream notebook, it's more or less finding new dogs at new layers, is sort of how it works. Cool, so unless there's more questions, so one thing I just want to announce is that I'm teaching 2 machine learning classes right now, or starting in like a week or 2. So if you're interested, one is going to be on Runway. So Runway is like a really cool GUI tool that allows you to sort of play with a lot of this stuff in a almost like Photoshop-like interface. So it's really helpful. That'll be a really good class for beginners. So we'll learn a lot about machine learning. We'll learn a lot about different models. So if you are interested in that class, I have some signups in the descriptions for these videos, so go check those out. And I'll say I'm teaching another class on StyleGAN 2, which will be probably more for the more technical folks. And you should probably have a very basic understanding of machine learning and be willing to use like command line tools and some Python. But that's going to be really fun. That's going to be stuff that I don't think anyone's ever taught before, but we'll see. So both of those classes are starting, I think not next week, but the week after. And I think in both classes I have a couple spots left. So if you're interested, please sign up and I'll see you then. Those classes are really cool. They're small class sizes, like maybe 15 people at most. I have a TA, Leah Coleman, who helps me with the classes, so you get a lot of help, unlike my videos where you're just sort of like watching and doing your own thing. And the hope is that you get to generate some cool projects out of those classes. They're 5 weeks each, so about an hour and a half each week of lectures, and then you've got some time to like generate ideas and make things. And Leah and I are around to help steer you or help you with anything you're stuck on. So it should be some pretty fun classes. I'm going to keep doing these live streams. Let me know if there's a better time for you, that sort of thing. So yeah. Oh, okay. So one more question. So from Sean, the model we're taking these layers from, what is it doing? It's detecting things in images. Yeah. So this is what's called Inception. And Inception was generated to take a large data set and classify those images, right? So it takes images of dogs, it takes images of puppies, of slugs. It basically is a lot of animal, and it's probably mostly animals, but there's probably some other things in there too. So basically what it's doing is this is a network that has been trained to find dogs. So guess what? There were a lot of dogs in these networks, and it found a lot of dogs. So these layers are sort of built more or less to find dogs or other things or other animals in there. So compare that to maybe you could train your own network on, say, a bunch of pieces of art, and it might learn Picasso's from Kandinsky's. You could then take that network and do DeepDream on that, and it would only excite based on those sort of maybe more stylistic patterns or shapes. So this is just using a pre-built, very popular Google network called ImageNet, and it's an Inception architecture, which there are different architectures. The architecture is important because that's what generates those layers. So if you were to use a different architecture, you would have different layer names. And I think Inception tends to be the one that most people use because it's a very deep network. Therefore, you have a lot of layers to play with. So yeah, that was a great question, though. Cool. All right, so Bug is yelling at me some more. It's time to go. So thanks everybody for watching. Again, there's lots of videos on my YouTube channel, so if you want to check some more things out, that'd be really great. And if not, I hope everyone stays safe. Hopefully you're having a restful weekend before the week starts up again. and I guess, wash your hands and whatnot. So see you next time.